Hello YouTube. Fixing this problem is beyond my knowledge, so I have elected to have a professional do it for me. And the professional happens to be a friend of mine by the name of Kenny Noj. And what follows is the first discussion we've had on how we're going to fix this problem. The content of the video is really high. You may want to watch it several times to get all of it. And it is only the first part. So here we go. Okay, we're here at Kenny Noj's and he's going to do the bottom end of the motor and we're going to talk about it a little bit. Do you have any idea what caused the problem?
Well, looking at it right now, no. We were assuming that on these Gen 5 and 6 motors, there's a double restrictor that's used underneath here that people forget to take out. It looks just like this pressure relief valve. There's one down in there, which is a restrictor, so it forces oil to go through the oil cooler. A lot of people plug these off, and unfortunately, that restrictor is only about a 1/4 inch hole, so that's your main oil feed for the whole engine. Fortunately, that was not it. Glenn and I pulled the plug and you could see that it was not in there. So we're back to kind of assuming what happened. All 3 center mains, maybe the crank could have a crack in it. We could clean it and mag it, but it's most likely with the heat and all the everything that happened here, it's probably got all kinds of spider web cracks in it there. So that's all I can assume. These cranks are a cast crank. They're not like a race car crank, but seem to be fine for stock applications.
So what are we going to do to fix the problem?
Well, we're probably going to strip the block first. We're going to check the line hone on the mains first. We're going to see how distorted these caps got. You can see the black heat just got sucked right into that cast iron. And what it'll do is it'll take this cap and pull it together. So we make sure the caps all register and fit. Maybe we'll replace the fasteners, and at that point we're gonna mock up probably and get a bearing size. After the crank comes, we'll be able to work backwards, decide what we want for oil clearance and what the line bore size will be. After that, then we'll line bore and then finish line honing it, and then we'll have probably 3/1000 oil clearance is what we'll target. 2 on the rods. Looks like we're probably gonna go 30 over. The cylinders are pretty clean, just original. This still has a GM bearing in it from 1994. So there's a date code on the back if you're ever wondering. I had one here. Where did I put that one?
There.
Oh, yeah. GM labels them all. So if you look right there, you'll see a 94, 2, and then the GM part number right there. So untouched since 94.
All right, and again, the question: what are we going to do to fix it?
Well, we're going to make sure all the oil clearance is good. We're going to put an aftermarket crank in here, probably a Cali's crank and rods and pistons from Mall. It's more of a performance, something that's probably good for over 1,000 horse. We're only looking to make 600 on pump gas, something for bracket racing and doing the gasser stuff. So we're going to start there. We'll get that stuff ordered tomorrow. And meanwhile, we'll get this block cleaned. We'll probably bake and blast it, clean all the stuff out of the oil galleys, everything out of all the plugs will come out, will get stripped, cleaned. And at that point, we always start at the bottom. We're gonna get the line honed in first. After that's established in that center line, then we'll go and deck it. We have fixturing from BHJ, which allows us to maintain a 90-degree to the center line of the crankshaft and a height, so everything's parallel end to end, the same height. Once that's done, then we're able to bore off that deck, and we know that our cylinders now will be perpendicular to the axis and to the deck. And then after that, it'll go into the CV616. We'll hone it. We usually leave about 10 thousandths in there. We'll use torque plates, and we're targeting. We'll use a profilometer. We'll measure the surface finish. We'll target what the recommendation is from the manufacturers. Sometimes on an RA level, if you just keep it simple, anywhere between 28 and 30 is what I target. That gives you enough valley to control the oil and not either starve the oil or maintain that the oil gets away from the ring and doesn't get above it. So one of the upgrades is going to be, we're going to go away from these original I-beam GM rods. I'm not going to say they're junk, but maybe for the application, since we're starting over, we're going to put a 4 1/4 stroke in here. The original stroke was a 4-inch stroke. For the same price, we can stroke this and we can pick up 40 cubic inch. So that's the plan. And with that, we'll use a H-beam rod with probably a 2000 series rod bolt. That's the alloy they use to make that rod bolt. That's really the weakest link in the bolts. If you ever go on one of the manufacturer's websites, you'll see they offer them in 3 different series hardware. Not everybody, but like some companies have their own, but Eagle, Scat, they use ARP rod bolts. You'll see a 8740, then a 2000 series, and then there's an L19. All have different tensile strength, and they require different bolt stretch. So all you're doing is increasing that strength, because that rod bolt is what wants to break. And that's what we're going to go with. And a piston, we're probably going to stay on pump gas, but it's up to Glenn. He hasn't decided. He's going to let me know tomorrow.
Yeah.
And we'll base it on the heads or an Edelbrock with a 90 cc chamber. So we'll work backwards. We'll figure out what the bore and stroke will be and what piston we want. We want to make sure that it has enough eyebrow in it for a valve relief so that we don't have to cut any pistons. Most of the manufacturers today, off the shelf, offer pistons that are already done. 30 years ago, we used to have to cut pistons all the time for valve relief. So hopefully that keeps the price down and the cost down for anybody that's building an aftermarket engine. Pump gas still, that's what Glenn and I discussed. This is for a 4 1/4 stroke. As you can see, the wrist pin's moved up into the oil groove.
And they do that so that the head of the piston is even with the deck.
Well, what they're doing is, with the increased stroke, yes, this piston would stick out. So this
Right.
piston's made for a 4 1/4 stroke, and if you look on the rod, it says right here, it's a 6-inch 385 rod. So that's center distance from bore to bore, from wrist pin to rod bearing bore. So when you do the math, you do that, and then you do the pin height, which they give you on here, which I believe is 1-inch 270. You add that up with half the stroke, and you'll get a 9.2 deck height, which is a stock Chevrolet.
So when we stroke this, what is this displacement?
It's like a 496, so 496 cubic inch.
Okay.
Decent piston, not full race, but come with a coated patch. They come with their rings. As you can see, it's got a good eyebrow, so we shouldn't have to do any piston to valve clearance, which will be nice. They use a 16th, 16th, and 3/16 ring, which is more of a standard performance ring. Since it's not full race, we want some durability there. It might be parked more than it's on the track, so this way we don't have to worry about anything corroding or anything like that, like a thin ring might do.
Okay.
This is the support rail. This goes on, since that wrist pin now goes up into the oil galley.
Right.
I'm sorry, the
pin.
oil ring receiver groove.
Yeah.
This supports the oil ring in those 2 spots where it's clearanced out.
Okay.
So this will go on first. As you can see, groove lock spacer. They make them for so many bores, so there's a range of these depending on what the bore size is. Expander rings. I don't know who makes their rings. I guess we could call them and ask them. It could be Total Seal, it could be Hastings. There's several manufacturers. Sometimes they say on them. I'm just looking. So I don't see anything written on here. It just says top. That's just their top moly rings. You can see it's molybdenum coated on the outside. It's a cast ring. It's not steel.
All right.
So it's more of a conventional ring set. The second ring should be just a tapered cast ring. So I think this is a barrel face. So when they make this ring, it's got a crown to it. as a radius. It looks flat, but really it's not. So very standard ring set, nothing exotic for this. Trying to keep it very simple. They come with their Wiseco, I don't know what these weigh, sometimes they tell you, but we'll find out when we balance it. Just a standard ring, nothing special.
And will this be lighter than the stock ones?
Wrist pin. Oh yeah, definitely lighter than the stock ones. The whole assembly is going to be a lot lighter than the stock ones. When we get it balanced, we'll figure out the bob weight, the rods, the pistons, wrist pin, rings, clips, and the rail for the support for the rings. So we went with the Cali's CompuStar rods. You can't beat the CompuStar stuff for what we're doing. I'm not going to say I would use this in a full race blown alcohol car, but for this I think they'll be great. As I said, the rod is a 6-inch 385 rod. It gives you, they've already weighed them, so that's their average weight. If you look in grams, total weight, rotating, reciprocating. So these are the same numbers we'll verify when we balance this. So it's always nice to have this, just because you know it's apples to apples. They give you the big end tolerances, the pin, what they recommend for torque, and you're going to see bolt stretch. So bolt stretch is kind of key. When we get into the assembly part, we'll explain that a little bit more. If you think about it, everybody's torque wrench could be different and calibrated differently. So mine might say 100, it might be 90 pounds, but maybe it's 110 if you could calibrate it some way. Glenn's might only be 65 pounds. So by going to a stretch, you're using the alloy of this rod bolt. They already predetermined. The stretch is what maintains the torque. You're literally taking it like a rubber band, but you're not reaching it's in its elastic point still. If you go beyond that, it'll get memory and stay there. So always the key is the fasteners. I believe these fasteners, sorry I don't remember. These are L19, which is a really good alloy. So what they do is when they're looking for more horsepower, sometimes the weakest point is the rod bolt.
Right.
And you'll see there's mostly there's three classifications of hardware they use. They'll start with, I think it's 8740, and then they'll go to a 2000 series, and then the L19. So they require different stretch and different torque. Usually if you follow the instructions, everything works out well.
So we're using their bolts rather than ARPs?
Well, they make these for them. If you look, they are listed as ARP.
Okay.
Let me open this, and you can see it a little better. Yep, so if you look on there, you'll see the ARP, L19, I don't know what the 14 is. Most of the good manufacturers all use good hardware. If you buy some of the offshore stuff, it might not be on there, and I would question what it is.
Okay.
For their other, I know Cali's, when you get into their ultra rods, they have their own bolts that are made. I don't know who makes them for them. So that's a whole different ball game. Most of the twin turbo stuff that we do, anything with like 1500 horse and up, we'll use their ultra rods and their bolts. Manley also does the same thing. If you have to replace bolts in a Manley rod, you can only buy them from Manley. ARP makes them for them, but specific. Okay. And it's just dimensionally a little bit different in length and shoulder. So just something to think about. So that's that. We decided to go with some coated bearings. King Racing bearings are a really nice bearing. Lately, since COVID, it was about availability, unfortunately, on a lot of stuff. I'm not going to open them, but they basically have a coating on here. It's some type of poly coating that they would put on. As you read, they do piston skirts and different things. So we went up to upgrade to a coated rod and main bearing.
Outstanding.
Mainly, I'm not going to say it needs it. I don't use them like in every build, but I know Glenn wanted to film this. I thought it'd be a good opportunity to let people know what's out there if they want to do something different. And what it does is it kind of protects it. If you think if it was like a dry start or something, it's like a coating on there. It's kind of like a Teflon pan, right? It won't stick.
Right.
So you won't transfer material or something like that.
Kind of like insurance to keep it from spinning again.
Yeah, well, hopefully. I mean, if everything's right, it shouldn't spin. Right? If the oil's there and you're hydrostatically holding that pressure, it should support the load. So, coated bearings. We also opted for Durabond's coated cam bearings. They're performance ones. Just a nice option. You know, the cam bearing doesn't reciprocate. It's just like a bushing, and you can see that black coating on there.
Yep.
That's the coating. And they basically mask it off, spray it on. I think it's cured probably through an oven, kind of like what Glenn would do with powder coating. Fortunately, when you go to a one-piece forged steel crank on these Gen 5, Gen 6s, they were originally externally balanced on both ends. The forged steel cranks that the manufacturers make now, Scat, Eagle, CompuStar, Manley, they go to an externally balanced. So they figure that weight into the blank of the crankshaft. So what we have to do is we have to now buy the right balancer and the right flywheel or flex plate so that the balancing is internal. That means they're neutral. There's no weight on there. So when we get into the balance, I'll explain that a little bit more and we'll be able to see the difference. I'll show you current state, what it looked like, how many grams it was, and then what it is on the new one. I went with a Summit one just because it was readily available.
Yeah, that's actually what's on there now.
Oh, great. I don't know who makes them for them.
Yeah.
I think their products are good. I don't use a lot of Summit stuff, but certain things I might buy.
Yeah.
If this was maybe a 1100 horsepower motor, we might step up to an ATI balancer or something that's serviceable. But they came out with these. They almost look like a Rimac one, so I don't know really who makes them. But I think for this application, they'll be fine.
Great.
All right, Glenn, I think that's it for the parts. Since we're only doing the short block, you're going to finish the rest at your shop. We might as well go over to the machining area. Unfortunately, I don't have the block here right now. We roughed out the new main caps and everything, and I wanted to get it to my friend Jim Zag. He's bacon blasting it for me. Does a nice job. He'll bring it up to like 700 degrees, burns everything off of it, and then we'll shop blast the whole block. So let's go to the machining area and we'll take a look at the caps, the new caps, the replacement, and why we did it. I'm probably not going to take it out, Glenn, for now, if that's okay with you.
That's right. Fine with me.
It'll get washed before we do anything. As you can see, it has like rust inhibitors on it, and it's pretty tacky on there. So
Right.
this is a Scat forging. I believe these come from overseas, unfortunately. Most of your manufacturers, this grade of crankshaft does. A lot of them are finished here in the States. So all the machining might be done here, some might not be. When you buy a CompuStar crank, they offer a machine shop grade and a consumer grade. If you look in the part number, you might not realize that it's the same crank, only it's finished outside of the United States or at a supplier, not internally at Cali's. Most of the Scat stuff is finished in the States that I know of. I think Eagle is too. These are good cranks. We've used them up to 1,000 horsepower. They seem to be fine. Not going to tell you they won't break. Everything breaks. But it's much better than the stock crank we had in there, which was just a cast steel lightweight crank from 1994, right?
No, 1994. You're right.
Yep. If you ever wonder what year, how we knew that is on the back of the original bearings, which I think we have a couple here.
Yeah.
If you ever wanted to know, General Motors was kind enough to mark them. Here's one that's not spun. And there it is. Their part number, aluminum 100, 2 of 94. So 2004, or 2090, or 1994, sorry. So it's been around a long time. I'm really surprised it held up as good as it did for the little bit of abuse that Glenn gave it.
Well, it's only, supposedly it only had 46,000 on it.
Yeah, I can't really tell you why. But we're gonna start over.
We're gonna fix it.
Yeah, we're gonna fix it. Here's some of the bearings. We can lay them out and we can kind of look at a little bit of the carnage of what happened. I'll put them on the table and we'll slide this crank over. And this was a pair of bearings also. And if you can see, the groove is completely gone. It's been smeared over by all the material. This bearing literally spun inside the housing and was like welded to the crankshaft and then broke loose. If you see, there's a little bearing tang right there, and you see these are all broke off. That's supposed to keep it from rotating and hold its position as a registration.
Yeah, when I took it out, I could literally spin it all the way around.
Oh yeah. The thrust is, you can see there's some debris in there. That's kind of what that is.
That's what I was worried about with the cam, but you said it was all right.
No, the cam looked good. I mean, this is soft. This is made to absorb and penetrate any this material's soft, so all that stuff gets embedded into the camshaft is, I believe it's like a 8620 blank heat treated, so I don't think it can take some abuse. So we have these caps. What happens is, I wish I had the block here, but we're gonna follow up when it comes back from Bacon Blast. These caps have a registration where they fit into the block. If anybody's done, I'm sure you all have, where you put this in and you notice it stays high because you actually have to draw it down into the block. And what that's for is so this registration holds this position. Without that position, your 2.5 to 3 thousandths oil clearance could be held up, and now you'd have this effect. Instead of it being aligned, you're like this, and the bearing will immediately tear itself up. So real critical. Mostly every block that we do here, everything gets line honed, everything gets fitted, because when you go to assembly, you want to guarantee what the oil clearance is, the bearing crush, and what we do is we maintain a new fresh center line, so when that crank spins, it's not trying to do this across all the main webs. And when we do the line hone, we'll look into it a little bit more. I'll explain how it works. There's a lot of question about what you're really doing there. All we're really doing is we're using an abrasive to hone. So we're removing material, and the way the hone manual is designed, it maintains a center line. We'll check the run on of it, we'll put it on position, and then it uses pressure. Just like if you were sanding paint on a fender, if you want to take more off, you just push a little harder. We do the same thing here. You want to have enough force on those stones because that's how they maintain their sharpness. If you looked at under a microscope at that stone, you're going to see all these little pieces that are made. It's either it's an abrasive like silicon carbide or whatever they're using, some type of oxides. So in order for that to stay true, as you break it down, it reveals a new edge. So all those little pieces, and depending on the grit is the size changes. So it's no different than you going from a 60 grit sandpaper to a 400. The stones that I use do the same thing. Only what happens here is my stone, I can't sharpen it, but how I do keep it sharp is you want it to fatigue and break away. So the substrate, which is like the glue that all holds us all together, it allows it to separate and reveals a new edge every time. Sometimes you've probably seen somebody where they'll dress a stone with a diamond. All they're doing is that diamond's harder than the substrate and the materials are in the stone, and it basically removes it and opens up and exposes that stone to all those new edges.
We're going to stop right here because it's a lot to absorb, and we'll put out more next week. And we actually might see some machine work next week. If you enjoyed this video, there will be more.